Hello, everybody. This is Mr. Collins. Today, we're going to go through some notes about heat. This is dealing with learning target 42. I can explain the difference between heat absorption on land and heat absorption on water. The essential vocab that we are covering today is heat transfer, heat absorption, and your old favorites from 6th grade, radiation, conduction, and convection. Heat transfer is simply the way that heat energy is moved from place to place. There are three major types of heat transfer: radiation, traveling through space in the form of waves; conduction, traveling by physical contact; and convection, through the motion and the movement of fluids like air and liquids. Heat energy moves always from the hotter object to the colder object. For example, if you were to be holding some ice in your hands, energy is transferring from the hand, which is warmer, to the ice, which is colder. If you were to get some toast out of the toaster and put some butter on it, energy is transferring from the toast, which is warmer, to the butter, which is colder. Conduction is the transfer of heat energy by direct contact. So here a person is holding a metal rod in a fire. That metal rod is warming up, and eventually this person's hand is going to feel pretty warm because of the physical contact or the direct touch. Convection is the transfer of heat energy by differences in density. In this case, water in a pot on a stove, the source of the water that's closer to the heat will warm up, molecules will expand and become less dense, warm water rises. As it rises, it cools down and sinks back down. Heats up, rises, cools down, sinks down, heats up, moves up, sinks down, cools down. Convection. Same thing goes in the atmosphere, not just water, but any fluid. Gases, liquids are both fluids. In the atmosphere, warm air will rise and cool down and sink. The cooler air then rises and sinks, rises and sinks. Convection. Third method of energy transfer or heat transfer is through radiation. Radiation is the transfer of energy in the form of waves. Energy from the sun is traveling through space in the form of radiation waves to heat up the Earth. About 70% of that solar radiation that comes from the sun towards the Earth gets absorbed. Most of it is absorbed in the land or the water, and some of it is absorbed in the clouds. About 30% of that radiation energy gets reflected, either reflected by clouds, gets reflected by the atmosphere, or it could get reflected by the surface of the Earth. Let's see if you can label this picture with convection, conduction, or radiation. This person grabbing the pot handle, red is representing warm, looks like he's going to experience heat transfer through the method of conduction. Inside of the pot where the water is boiling, closer to the burner, closer to the heat source, it's getting warm. Warm stuff is rising. Getting cold. Cold stuff is sinking. We have changes in density. Convection. Energy transferring from the burner into space, radiation. How heat transfer works in the atmosphere is very similar. Radiation from the sun is transferring energy through space to heat up the surface, whether it is the ground or the water. That surface of the earth, which is warm, will transfer heat into the air where the air is touching the ground through conduction, physical contact. Now the air, which is a fluid, starts to flow. The warm air begins to rise through convection. On the surface of the earth, heat absorption is the way a material takes in heat energy. Land absorbs and gives off heat differently than water. Land absorbs heat faster than water. But land surfaces also lose their heat faster than water. The sun's radiation does not go deep into the soil, so the heat enters the surface of the earth and leaves the surface of the earth fairly quickly. Water absorbs heat slower than land, but water holds the heat longer. The sun's radiation can shine deep into the water, and this causes it to hold that heat in longer. Let's think of this: a kiddie pool versus a sandbox. In the daytime, when the sun is shining bright, which of these heats up faster? The sandbox. Which of these heats up slower? The kiddie pool. Which of these two cools down faster, loses the energy quicker? The sand. Which of these cools slower but holds that heat in longer? Water. Rewinding back to astronomy from first trimester, when do we get the most solar radiation, the most direct solar radiation? Do we tend to get it in the winter, in the spring, in the summer, in the fall or autumn? We tend to get more energy from the sun directly in those summer months. Have you ever noticed that lakes are colder at the beginning of summer than they are at the end of summer? Colder in June than they are in August? This is because water takes a while to heat up, but it holds that energy longer. At this point, you're going to go to your Google Forms and fill in your notes summary sheet. How are heat transfer and heat absorption different? 2. What are the 3 ways that heat is transferred? 3. How do land and water absorb heat differently?